that started. All right, good morning, everybody. If you would go to Canvas and go to your home page. Good morning. Can't get my screen to come out. There we go. All right, so if you're in Canvas and you're looking at your home page, you should have, let's make this clear because all of that is last semester. I don't know why it's still popping up. All right, so you should have turned in your DNA profiling gizmo. We're going to look at a DNA evidence PowerPoint. So that's what you want to click on for today. Okay. Now we're going to watch a video together, but I need you to download the PowerPoint. And start reading this over. And like I said, there's a video question. So there's some questions here and then some questions that go with the video. So we're going to watch the video together, but at least read. Everything is just a read up to the video question. So download that while we're waiting for everybody to come in. And also, while we're waiting for everybody to come in, if you have not submitted your Gizmo worksheet, please make sure that you do that as well. All right, good morning. If you just logged in, we're in Canvas. We're on the assignment that said DNA evidence PowerPoint. We're going to watch the video together because that is part of the questions, but the first part is just reading the PowerPoint. All right, everybody else is late after this, so I'm going to go ahead and get started. All right, so up to now we've talked about what is DNA, and so this one kind of reviews that for you. DNA stands for deoxyribonucleic acid and contains genetic information. It is found in the ribosomes located, sorry, it's found in the chromosomes located in the nucleus of our cells. So you kind of have to remember a little biology. Remember what all living things are made of cells. We are eukaryotes, which means we have a nucleus in our cells. There are some cells that don't have a nucleus. Our cells have a nucleus, and inside that nucleus, you have the genetic material called DNA. All right. So then you have these strands of chromosomes. Okay. And the DNA is made up of a sugar, which is your anything that ends in OSE is a sugar. Deoxyribose is the name of the sugar in DNA, as opposed to RNA, which is ribose sugar. So DNA has deoxyribose and a phosphate molecule. We always refer to DNA as like a ladder. So the sides of the ladder, they're calling it the backbone, are your sugar and your phosphate. Then the steps of the ladder, the rungs of the ladder, are made up of your nucleotides, which are nitrogen bases, and they consist of 4 different kinds: adenine and thymine, guanine, and cytosine, and they pair up. So if you look at the picture, and again, if you remember from biology, that they are matching pairs. They link together like puzzle pieces. So T always matches A and G always matches C. Okay. And depending on the arrangement, the same way we have 26 letters in the alphabet, and you can arrange that to spell everybody's name is spelled differently. There's no 2 people in this class that have the same name, but you're using the same alphabet. So think of it like that. When you are thinking of, there are 20 different types of amino acids, and depending on how we arrange them, will determine what kind of protein we're going to make. So they make up the genetic code. So again, this is just a visual of what it looks like. All right, good morning, Jonathan. We're in Canvas looking at DNA evidence PowerPoint. All right, remember, you're supposed to be on camera. Okay, so this is just a blown up version of what we were just saying. So the backbones or the sides of the DNA are the sugar and the phosphate, and then the nitrogen bases, guanine, cytosine, adenine, and thymine, make up the middle, and they are held together by a hydrogen bond. So that's what this is showing you. Okay, again, this is just a schematic so that you know what we're talking about when we say DNA. All right. The important part is, how do we use it in forensics? Okay, so each person's DNA is different from each other except for identical twins. Right, DNA collected from the crime scene can either link a suspect to the evidence or eliminate the suspects, similar to the fingerprints. And we're going to do fingerprints as our next unit. And remember, DNA testing is fairly new. They are now solving old cases because now they know how to use DNA evidence. They didn't know how to do that before, so they only had fingerprints. All right, DNA can identify the victim through DNA from relatives, even though nobody can be found. All right, DNA can link the crime scene together by linking the same perpetrator to different scenes locally, statewide, and across the nation. So this is how they get serial killers who've done crimes in different states, is that they have DNA evidence from the victim or the crime scene, and they compare it. When they notice that there's a similar pattern to the crime, they start comparing the DNA evidence. It can place an individual at the crime scene, in a home, or in a room where the suspect claimed they were not. All right, DNA can refute the claim of self-defense and put a weapon in the suspect's hand. It can change the story from alibi to consent. Okay. All right. So they gave you a picture here of fingerprints of an individual and DNA strands. And notice there's some slight variation. We're going to be looking at that. All right, what factors affect DNA evidence? Several factors affect DNA evidence left at the crime scene, such as environmental factors, heat, sunlight, moisture, bacteria, and mold. Meaning that if the, especially if the body was found outside, you have to worry about all of these things. Not so much inside, maybe bacteria and mold on the inside, but you have to worry about heat, sunlight, moisture, mold, bacteria, always on the outside. Therefore, not all DNA evidence will result in usable profile. Further, DNA testing cannot identify when the suspect was at the crime scene or for how long. Okay, so that part of it, it's no good for. It's just good for identifying the person, but not time of death or um, how long it took them to commit the crime, that sort of thing. All right. This is a term you have to know. CODIS stands for Combined DNA Index System, which is an electronic database of DNA profiles that can identify suspects. The DNA profiles from the individual convicted of certain crimes such as rape, murder, child abuse, or entered into CODIS, are entered into CODIS and help the officers identify possible suspects when no other suspect existed. All right, so again, this is modern technology. We now have a database for everything. So once your information, like once your fingerprints are on file, everybody can access your fingerprints in the country. Same thing with the DNA. Once it's on file, then anybody can access it across the country. All right, did you know each human cell contains 3 billion DNA base pairs? That's the AT and the GC. Our unique DNA amounts to 1% or 3 million base pairs. Okay. All righty. All right. So this is where you need to get out pen and paper, not pen and paper, but you all make a Google um, notepad because you're going to answer these questions. So we're going to call, what is this? This is slide 6. And you're going to write down the question, who done it? And we're going to look at this and we're going to say, which suspect matches the blood stain? So just in this first column right here, we have this blood stain is in the middle. And then you have seven different suspects. So you're going to compare the DNA chromographic picture. So compare those 7 columns to the one in the middle. And you decide which one is closest. Hi, good morning, Anthony. We are in Canvas. You need to download the DNA evidence PowerPoint and then be ready to write. All right, so we are answering this question. So these 3 questions are questions that you have to answer. And then we're going to watch the video, and then you have to answer the video questions. So when you submit your answer sheet to me, now I don't need the PowerPoint back. I need your Google Doc, and your Google Doc should have a title at the top, DNA evidence, PowerPoint. And starting with this one, page 6, who done it? Which suspect matches the blood stain? So then you can say suspect number, whichever one you pick. All right, the column in the middle. goes with B. It says, who's your daddy? Which sample is most likely to be the father? So they have samples on the side, M and C, and they want to know, is F1 or F2 the closer DNA sample? So you're going to write the question, who's daddy, and you're going to say F1 or F2. All right, for C, you're going to write identical or not. And we have set to, twins can be fraternal. Twins just mean that you were born at the same time, that you don't have to be identical. So they want to know, is set A, B, C, or D? Which of these are identical twins based on the DNA pattern? So I'll give you a few minutes to look at that. Oh. All right, you'll have time to come back to this. We're going to watch a video, and then based on the video, you're going to answer the questions on the last two slides. The video link is also in the assignment thing in case you need to go back and watch it again. But we're going to watch it together. All righty.
It was one of the most sensational murders of the century, and it was never solved. Marilyn Shepard, the wife of a handsome surgeon, killed by more than 15 blows to her head. Dr. Sam Shepard was convicted of murder in a highly publicized trial. Sentenced to life in prison, he served 10 years until the U.S. Supreme Court overturned his conviction. In a second trial, Shepard was acquitted, but suspicions about his guilt remained.
My mother was murdered. I want my mother's murder solved.
Now the son of Marilyn and Sam Shepard is taking the case to court one final time, suing the state of Ohio for $2 million for the wrongful imprisonment of his father. Gilbert needs to convince a jury beyond all reasonable doubt that Shepard did not kill his wife.
Unless we do it on rebuttal.
He'd like to use a powerful new scientific tool, unavailable at the earlier trials, that could potentially settle the question once and for all.
Oops.
Forensic DNA analysis. Human DNA is made up of billions of chemical building blocks.
It seems to be buffering this morning.
At certain locations, the arrangement of these building blocks varies in predictable ways from one individual to another. These variations are called alleles, and they are the key in DNA fingerprinting. If enough of them can be observed and compared, these genetic variations can identify an individual as uniquely as a fingerprint. Scientists are now able to compare the DNA found at crime scenes to DNA taken from suspects. As valuable as it may be in prosecuting crime, it's DNA's ability to rule out suspects that holds the most power. Gilbert enlists the aid of Dr. Mohammed Tahir, a forensic DNA specialist in Indianapolis. He sends Tahir a set of artifacts, all stained with blood from the crime. Among them, a wood chip lifted from the stairs of the Shepherd's house, a section of flooring from the porch. Tahir chooses a test called DQA1. The DQA1 test is designed to work with tiny quantities of DNA, but it isn't very discriminating. The test can identify only 8 different alleles in 42 possible combinations. His first step is to increase the quantity of DNA the test will have to work with. To do this, he places a portion of each crime scene sample into a vial. Then he adds a chemical cocktail that stimulates the process of DNA replication. The samples are then placed into a thermal cycler, which speeds the process of replication through precise warming and cooling of the samples. Within hours, any DNA present in the original samples has replicated into millions of copies. He obtains Marilyn's DNA from a few strands of her hair collected after the murder. Finding Dr. Shepherd's DNA proves more difficult. So Sam Reese Shepherd grants permission to have his father's body exhumed for tissue sampling. Dr. Tahir can now complete the testing. The DNA from each of the samples is now poured over the sensitized paper test strips that will reveal the long-awaited results. Each test strip is printed with a set of numbers. The numbers refer to the 8 specific alleles the test can detect. Indicators turn blue when the test has detected a specific allele. In this example, the test has detected the number 2 allele and the 4.1 allele. Once Tahir obtains a test strip for each DNA sample, he will carefully chart the results and present his findings to the defense team. At the first trial, the prosecution argued that the blood trail came from a weapon dripping with Marilyn's blood, carried by the killer as he fled the house. What does the DNA show? The porch stain tests positive for the 4.1 allele only. The wood chip also shows the 4.1, as well as the alleles 1.1, 2, and 3. How does this compare to Marilyn Shepherd's DNA? Her alleles turn out to be 1.1 and 1.3. One or both of Marilyn's alleles are absent from the blood trail samples. Marilyn is therefore excluded as a donor to these stains. So the prosecution's theory was wrong. A murder weapon dripping with Marilyn's blood didn't leave the blood trail. Then whose blood was it? Was it Dr. Shepherd? His alleles turn out to be 1.2 and 1.3. So Dr. Shepherd is also excluded from the blood trail.
All right. So so that's the video. Now you want to come back to the PowerPoint. Oh, where'd my PowerPoint go? I think I clicked on it from there. All right, so in the time that's left, and like I said, the link is there for you to watch again if you want to. On the time that's left, you need to, and you need to answer these on the same page that you're writing the answer to those questions. Pick three. Oh, it says which three statements below are true. So just write the statements down that are true statements based on the video, and then also answer all four of these questions based on the video. Okay. And then again, you don't have to highlight it on here. You can just write the answers on the one document that you're going to submit with all of the answers for slides 6, 7, and 8. All right, so in the time that's left, I'll leave you to that. Again, with this one, the blood stain is the one in the middle. So you're trying to figure out which bands or which alleles are most similar to the one in the middle. All right. The strip for B, you have the mother, the child, and then you have two suspect fathers. So you have to figure out who's the father. Again, the first one is the mother, then the child, and then father one and father two. And then the last one, you have sets of identical, or you're trying to figure out if they're twins for sure, but which ones are identical. And you can call them A, B, C, or D. And so after that, questions on slides 7 and 8 refer to what you saw in the video. I'm going to stop sharing so I can do attendance. And when I look at GoGuardian, I shouldn't see folks looking at me. Everybody should be looking at their PowerPoint and answering the PowerPoint, or have a Google Doc up where you're answering your questions. Okay. Also shouldn't see where you've been idle for 20 minutes. And I've said it before that if you are logged in and your assignments are late, there's something wrong with looking at you've been idle for 20, 25 minutes and then you can't get your assignment done in the allotted time. You deserve a late grade on your assignment. Okay. Okay, folks. If you have no questions for me, time is up. See you tomorrow.